Okay, Mick Barrett here again. In our little experiment to try to figure out what language models are, what that means exactly, we're going to try a little thought experiment. We're going to imagine that we trained a language model only on Jane Austen's works. And you can do this if you want. We may set up a lab doing this and see the results of it. But for now, we're just going to treat this as a thought experiment. What would this model output? So our parameters are this is a closed world. This is only Jane Austen's world. And so what it'll do is it won't memorize and regurgitate Jane Austen text. What it'll do is it'll learn her patterns of writing. Statistically, it will learn the words she uses, what words are related to other words. And if you ask it a question like, write a story about something, it will sort of predict what she may have written based on the statistics of, her writing, her corpus, her works. This is not memorization. This is a statistical mapping. It looks at covariance and looks at patterns within her data, It makes prediction. If you ask it something on its scope, like what is a laptop, it doesn't know. It's not its world. It's not its training thing. It's not because it's stupid. It's because that's not its training data. And all training data has bias. If I go to Midjourney and I type in, a photo of Wonder Woman, it shows me Gal Gadot. There's a Wonder Woman before Gal Gadot called Linda Carter. Doesn't show me Linda Carter. It shows me Gal Gadot. What that means is Midjourney is trained on Gal Gadot, films, because that's what it shows. It maps sort of Wonder Woman to Gal Gadot, or if you do a drawing of Wonder Woman, it will probably do a 2C comic version of that. So what these language models do is they predict ours. They're just, some people call them statistical parrots. That may be demeaning a little bit about how amazing they actually are. It's remarkable what they do given how they work. They are making predictions. They make very good predictions. It's sort of stunning how good they are at what they do, given how they work. Because they're just making predictions, but they get better and better at making these predictions. But because they make predictions, they can make mistakes. They can predict things wrong. And we're going to get into that quite a bit. We're going to get into how do we know it did a good job. Sometimes it's qualitative. Like here, I made some images, and we'll do this down the road. We'll do image prompting for Midjourney, image prompting for VO3, for books, for scientific research, etc. This is what I imagine Jane Austen to look like. It probably looks nothing like Jane Austen. Maybe. Has her, she had, I forgot the thing called, the thing on her head. That is something I read. I forgot what it's called. A language model would know what it's called. She would know what it's called too, because it's in her world. In her world, if we trained it on her world would not know what a laptop is. So what these things are doing, and they're amazing, is they're probabilistic machines. If trained on Jane Austen data, it gets sort of the probabilistic estimates, the covariance of what Jane Austen might have written. There's not a database. We're not looking up and following her text. We're sort of generating a novel thing that she may have written. And they're remarkably good at this. They're remarkably good at, I'm not a super expert in Jane Austen. The way you would evaluate that, can it write like Jane Austen, is you get Jane Austen experts. You would generate text and ask them, well, does the scene feel like Jane Austen? If they're real experts, they would know everything she wrote, so they know that she did not write this. But if you sort of knew Jane Austen and knew her feel, a test would be, could you tell sort of generated Jane Austen from real Jane Austen? And that's a turn test, which we'll talk about a bit, mini turn test. We'll get into that in this video. What the essence of this video is these are statistical machines. They learn patterns. They don't do lookup. They don't do memorization. And our next video, we're going to talk about, okay, this is just the Jane Austen world. What if we take them to the internet world? Scale the entire internet. And that's what these quote unquote large language models are. So when we use the word large, we're talking about big, big data, like internet scale data. Data which it cost, 10 million, 20 million to train, just from the computing power to train the models. But you could train your own Jane Austen models. I don't know how much she has written, but in computer worlds, she hasn't written that much compared to what a computer can handle. Even if she's written 1,000 books, which I don't think so, I think it's maybe like 10 text stuff, whatever. I don't know. I'm not an expert in that. Um, you could definitely train a model on Jane Austen's corpus. We may do that as a experiment in this class. Technically, a project you could do if you're a student in this class. And it would be limited to the Jane Austen world. I'm certain that she'd never use the word laptop or hip hop or, whatever, or, stuff even out of her world in England. And so that's not in her world. But her patterns of writing, it's going to learn. It's going to learn her style of writing from the statistical covariance of the patterns. And the big language models, the large language models, will do this at an internet-wide scale. It'd be interesting. You could ask a large language model to restrict yourself just to Jane Austen's world. It'll try its best. But it'll probably creep in some stuff that wasn't in her world. You couldn't really get a large language model to truly be her world unless you only trained it on data from her time. Right now, you can go to Claude, Gemini, ChatGPT, and say, restrict yourself only to Jane Austen's universe and answer these questions. It'll know its best. It'll try. But things will creep in that it doesn't fully understand because it's just looking at statistical patterns. And it may throw in the word laptop. It might have Jane Austen use the word laptop. If you trained it purely only on Jane Austen data from scratch, it just doesn't know that exists. So it's not going to predict that because it's not in its training data. So in our next one, we're going to get into the next step scale, large language models. It's the same idea. If you train on data off identifiers, and it'll have different kinds of biases. I have another class where we talk about how to detect bias and what to do about bias. My bias here is this is my bias of what I think that's Emma, her most famous character, and my bias of what I think Jane Austen looks like. It could be, and probably is, way, way off. But it's also Midjourney bias because I use Midjourney to generate these images. It clearly is trained on left fashion images. I just had a critique of somebody who's saying, Jane Austen looks like a supermodel. She didn't look like a supermodel. I don't know. Anybody really knows exactly how she looked because there's only sketches of drawings. But it's true. The Midjourney bias is to make everybody look like they're in love. Use a different model trained on different data. It will have a different look and a different feel. We'll get into that because choosing the right language model for the test is going to be part of the prompt engineering experience. But we will get into that now. I'm already over time. I think I'm over 8 minutes, and I want to keep these to 5, certainly less than 10. So the major point of this is we're not memorizing. It's not. If we train it on Jane Austen data, it would not just regurgitate and spit out like a database exact Jane Austen quotes. It would learn statistical patterns within Jane Austen's work and make a prediction of what the next word would be, given her previous history of writing. And that same model is going to go to basically large language models. It's going to do the same thing, but at a much greater scale. So it's getting the patterns and rhythms. It's learning it statistically, the patterns and rhythms of Jane Austen, just like it learns the patterns and rhythms of the internet. But those patterns are much more complicated because they're the internet. They're not just one writer. And so if you wanted to truly do a Jane Austen generator, you should probably limit it to Jane Austen data, which you can do. It's not that much. But the idea, again, the idea of this video is not memorization. It's not just looking up and spitting out something. It's looking at patterns, then generating, predicting novel sequences based on the patterns that it's learned. Okay, that's it. We're almost at 10 minutes. I think at 10 minutes right now. So I'm just going to cut this to the next one. We're going to talk now about the next scale, large language models, which do the same thing, but now at scale. Okay? Take care.